So, yeah, I can see it was a tough week. Only half of the audience is here today. But anyway, we are stronger than the others. So we are here with Peter Inglesby, which will show us the descriptors. Peter, thank you.
Thank you, Luca. Good morning. So I'm going to be talking about discovering descriptors this morning. The descriptor protocol provides a generalization of attribute access. It's used a lot in the implementation of Python itself. I'm a bit concerned to see some core developers in the front row. We'll see what they've got to learn this morning. So this talk has three goals. Firstly, I want to explain the descriptor protocol to you. I want to show you what a descriptor is and how descriptors work. I want to demonstrate how descriptors are used in the implementation of Python itself. And finally, I want to provide you with some examples of how descriptors can be used in your own code. So, the one thing I want to point out at the start is that I'm using Python 3 here. I thought we'd try and make a great leap forward. All the examples here will work in Python 2, except that in Python 2 there are two kinds of objects. You have old-style objects and new-style objects. New-style objects inherit from object, and in Python 2 this inheritance has to be explicit. In Python 3 that's implicit, and so you won't see my classes inherit from object. You can pick up all the code for this talk at this GitHub URL here, so feel free to download that and follow along. Good, so let's get going. This is a class. All my classes are called C. I'm not feeling particularly inventive this morning. It's got two attributes. It's got a class attribute, which is set to 1, 2, 3, and every instance has got an instance attribute, which when the instance is instantiated is set to 4, 5, 6. So we can instantiate our class, and we can access the instance attribute and the class attribute with the usual dot notation on the instance. Now, a question for you. What's actually happening when we look up an attribute on an instance? Well, to understand this, you need to know that pretty much every Python object has a dictionary, or has access to a dictionary of its attributes. You can access this through the under dict attribute. And that shows that the instance has got, well, no surprise, an instance attribute with the value 456. Similarly, the class has an under dict. This has got a few more attributes in it, but the one we're interested in is our class attribute here. You'll also notice that this object is actually a dict proxy. That's just a name for a read-only dictionary. So when we look up an attribute on an instance, Python first checks to see whether the instance's name is in the instance's dictionary. If it's not, it then looks in the classes dictionary. After that, it will look up the base classes. I'm not going to talk about inheritance at all today, but the same kinds of principles apply. So where do descriptors come in? Well, if Python finds the attribute that you're looking for not in the instance dictionary but in the class dictionary, and if the corresponding attribute has a method called under_get, that gets called instead of returning the attribute. So I think it's best to give an example. This is a class. It defines a method called under_get. That makes it a descriptor. When we call under_get, we pass in a few arguments, and I'll come to what those mean shortly, but this time under_get just returns a random integer. So here's a class. It's got a class attribute, which is an instance of our random attribute class. I'm going to be saying the words class and instance and attribute quite a lot, so you'll have to get used to those this morning. We can instantiate our class and look in the instances dictionary, and we'll find that that's empty. So hopefully no surprises here. But we can check the classes dictionary, and we see that we've got our random attribute here. So if we look up the random attribute on our instance, that returns 8. It also prints out this guy here showing that our descriptor is being called. If I call it again, yes, it gives something other than 8. I had a nightmare last night where I kept getting the same number over and over again for this random attribute, but the gods are looking kindly on me this morning. Good. So, a descriptor is an object that defines at least one of the following 3 methods: under get, under set, and under delete. Now, I'm going to be talking about the first 2 this morning. Under delete, you can probably infer for yourself what that does. I'm going to show you a more interesting example. This is a class, again, it defines under get, which makes it a descriptor. The class itself has got both a name and a function here. And when we call under get, we call the instances function here, and we pass in an instance object, and I'll tell you what that instance is shortly. And we set in this instances objects dictionary an attribute with the name that we've previously stored, and we set that to the value of the function that we've just calculated. So in action, here's another class called C. It's got a method which takes a while to calculate. I've cheated a bit here and used sleep. And we've got a class attribute, which is an instance of our cached attribute. Its first argument to the constructor is a name attra, and its second argument is a function, which is our expensive calculation. So we can instantiate the class again. The instance dictionary is empty. When we try and look up the attra, it's taking a while, and that's because it's calling expensive calculation. Eventually, we get there, and it returns 42. We can now check our instance dictionary, and we see that's been populated with our attribute. And the next time we call, or the next time we look up the attribute on our instance, it happens instantaneously. So it's worth thinking about exactly what's happened here. When we first look up the attribute on the instance, Python doesn't find it in the instances dictionary, and so that results in a call to under get of this cached attribute object that does the expensive calculation and puts the result in the instances dictionary here. There are perhaps 2 reasons why you'd want to cache your attributes if they take a while to calculate. First of all, you don't want to be doing an expensive calculation every time you look up an attribute. Secondly, you might not even ever want to look the attribute up, and so you can postpone evaluation of it until you need it. So I'm going to talk a bit more about the mechanics of looking up attributes with an under get on a descriptor. So this is a rather useless example, except for pedagogical purposes. This descriptor, it just shouts when it's been called, and it tells you what arguments it's been called with. So here's an instance of a class that's got a noisy descriptor as a class attribute. And when we look up the attribute on the instance, we see that we're calling get on an instance of our noisy descriptor. Self is the instance of the noisy descriptor. Inst is an instance of our C object, and that is, in fact, I itself, and you can see that by comparing the memory addresses here and here, there. And the class is the class C. Now, you might be wondering why we pass in both an instance and a class if we can get the class from the instance. Now that's because you can also look up an attribute which is a descriptor on the class, and you might want different behavior for that. So there are various libraries which offer differing behavior when you look up attributes on a class and an instance, and that's done with descriptors. So there's a more familiar example which I'm going to discuss now, which might provide some motivation for why descriptors are implemented the way they are. Excuse me. So here's a class. It defines a single method, and we can call the method on an instance of the class, and we can also call the method on the class itself, passing in an instance of the class, and that gives exactly the same function call. So whenever you call a method on an instance, you can achieve exactly the same by calling the method on a class, passing in an instance as the first argument. The method attribute, when we look it up on an instance, is actually an instance of something called a bound method. So a bound method is basically a function whose first argument is already bound to a particular object, in this case I. When we look it up on the class, we just get a function back. This is a difference between Python 2 and Python 3. In Python 2, there's the concept of unbound methods, which are basically functions which are attached to a class and will, I think, raise a type error if the first argument that they're called with isn't an instance of that class. I think it was decided that that was too much hassle, and it was dropped in Python 3. And I'm getting nods from the front row. Thank you. In our instance dictionary, that's empty. So it must be the case that methods are stored in the classes dictionary, and indeed they are. So a function object is stored in the classes dictionary for the function's name. Now, functions are objects, as are most things in Python, and the function class defines a method called undo_get, which means the functions are descriptors. So we can call undo_get on our function, passing in an instance and a class, and that returns our bound method. Similarly, we can call undo_get, passing in no instance and still passing in our class, and this time we just get back our function. So I hope that provides a bit of context both for how method lookup works in Python and a bit of motivation for why descriptors can take both an instance in a class or no instance and a class. You might enjoy trying to implement function lookup in pure Python and trying to get the differing behavior. You might not enjoy that, depending on what kind of nerd you are. So we've talked about getting attributes. I'd like to now touch briefly on setting attributes. Here's our class from the start. We can set attributes on the class, and that will update the instances dictionary. One thing to note is that our class has got a class attribute that we can access through the instance. If we try and set the class attribute through the instance, that won't do quite what some people assume or expect. So that will, in fact, create a new entry in the instances dictionary, and that won't touch the class attribute at all. So it creates a new entry in the instances dictionary with the same name as the class attribute. So again, where do descriptors come in? Well, here's our noisy descriptor again. This time it's got a method called undo_set, which just prints out what arguments it's being called with. So when we try and set an attribute, which is in fact a settable descriptor, we see that the descriptor gets called again with the instance of our class I and a value. Notice this time that there's no class argument. There doesn't seem to be an interesting way of changing the behavior of setting an attribute depending on whether you're setting it on a class or an instance. So were you to call c.atcha equals 123, that would in fact override the descriptor in the classes dictionary, and you've now lost the descriptor for good. So that's probably not what you want to do. So let's see a less useless example. This is a class. It's got an under set method, which means it's a settable descriptor. When under set gets called, it checks to see whether the value it's getting called with is an instance of a particular type. This means that we can add some kind of static typing-ish. It's probably not really static typing because you don't get any of the real advantages of static typing, like the compiler helping you out, but it will prevent attributes being set with types that you don't intend. So here's a class. It's not called C. It's a person with a name and an age. The name must be a string, and the age has to be an integer. So we can set the name to Bill, set the age to 25. Everything just works. If we try and set the age to a string of 25, that will fail, and that raises a type error. Because when under set gets called, the first thing it does is check the type of the value it gets called with against the type that it knows the value ought to be. So this is quite useful, but it's only useful as far as your users want to play along with you. So there's nothing to stop a user accessing the internal dictionary directly and setting the age to something that's definitely not a number. What's next? We're going to talk about slots. Now, slots are a variation on attribute access. They're little used, but when they are used, they're extremely useful. So they serve a very definite purpose in Python code. So here's an example class. It's got a single class attribute called under slots, which is a list of strings x and y. What this means is that we can access attributes called x and y on instances of our class. But when we try and, say, set z to be a value, we get an attribute error telling us that our class object has no attribute called z. So slots are a way of restricting what attributes an instance of a class can have. And I'll talk a bit more shortly about why that's interesting and useful. So to understand what's going on here with the mechanics, the first thing you might do is to check the instances dictionary. But again, that raises an attribute error. Our C object has no attribute called under dict. So what's going on here? Well, when I said earlier that every Python object has access to its attributes in a dictionary, I slightly lied. Instances of classes with slots do not have dictionaries. So let's look at the class dictionary instead. This does exist, and you'll see that it's got two entries for x and y. So the class attribute x appears to be a member object. Now, this being a talk about descriptors, you won't be surprised to hear that member objects are, in fact, descriptors. And so we can call under get on them, and that this incantation here has the same effect as calling i.x. So we're passing in our instance and our class to the under get method of the x member object. Similarly, we can set attributes directly with the under set, passing in our instance and its value. And again, I don't have any more code to show you there. Can I just show off something that I'm really proud of? I can switch between sort of pressing space to tab through my talk. I Control C, and I can now interact directly. So we can see that no, I'm not going to do that. Sorry. Right, let's just carry on. What are slots for? Well, primarily I think they are for efficiency. So it's faster to look up attributes in a class with slots than it is to look up attributes in a dictionary. It's, objects with slots also have a lower memory footprint than objects with a dictionary, and that's because a dictionary obviously needs to have enough space for all its attributes and some overhead. So slots are useful when you've got lots and lots and lots of objects of the same class, and you can use slots to reduce the performance overhead of having all those objects. What slots are not for is security. So again, you can't stop a user of your code adding in a dictionary attribute to your class, which would then allow instances to have their own under dict, which would allow them to have access to any attribute. So slots are definitely not for security, and in fact, it's almost impossible, if not impossible, to properly sandbox Python in a way that you can give, in a way that you can allow users to run their own code and not screw up your system. So it's probably not worth trying. I'm going to talk next about properties. Properties are another variant on attribute access. They're quite similar to descriptors in many ways, and in fact they're implemented in terms of descriptors, but they're another useful tool in your armory. This is a class with whose instances have a single attribute called _x, and we have getters and setters for this attribute. Now, if you've done much Java recently, you're probably screaming at me and saying, no, there's a better way. But sometimes getters and setters can be useful. Sometimes you want to do things when you get or set an attribute, and properties provide another way of doing this. So our class C has got a class attribute called x, which is an instance of the property class. Well, when we create our property instance, we pass in a getter and a setter. And when we look up x on an instance of our class, the getter gets called. And when we set the value of x on an instance, the setter gets called. So let's see this in action. We've got an instance of our class. When we get x, that actually calls our getter here. And when we set x, that calls the setter and updates the instance dictionary. So I'll show you perhaps a more... let's talk about how these are implemented. Not surprisingly, property objects are descriptors. Property objects live in the class's dictionary, and you can call under and get on them, passing in an instance in a class, and that gives you, that has the same effect as calling i.x directly. Similarly, calling under set on the property descriptor has the same effect as calling i.x equals something directly. So, hello? I don't know. Sorry, I did wonder that. The only other usage of descriptor that I've come across is, of course, file descriptors, and file descriptors provide a kind of a handle on what a file is. I'm not really sure how that applies here, but if anyone's got any better ideas, let me know. Cool. 10 minutes, great. So a more useful example of properties. Here is a Mars probe. Do you remember a few years ago, I think a Mars probe crashed because it was a joint British-American project, I think, and the Brits were using metric measurements and the Americans were using imperial, and it was all fine until it came to land, and the probe got confused about how far off the surface of the planet it was. That would have all been fixed had they used properties correctly. So instances of our Mars probe class have an attribute which is the distance in meters, presumably above the surface of the planet. But you can access this both in terms of a distance in meters, but also a distance in yards. And we do that with getters and setters, but we wrap that nicely in a couple of properties. So we can create our Mars probe, we can set the distance in yards to be 120, and then access that in meters to be the correct value. So one thing that properties are good for is maintaining a single representation of an object state, but allowing access of that in different forms. So how should you choose between descriptors and properties? Well, I think properties work best when they know about the class. So our Mars probe properties needed to know that the Mars probe had an attribute called _distance meters. Conversely, I think descriptors are more general and can often apply to any class. So if you think back to our typed attribute descriptor, that didn't need to know anything about the class because the class told it what it needed to know when it was defined. If you want different behavior for classes and instances, use descriptors. I think that's probably self-explanatory. Now, properties are really just syntactic sugar, so you can implement properties easily using descriptors, and there's examples in all over the internet of how you can do that. So what that really means is that you should experiment. So if you decide to use a descriptor or a property, just try it out using both and see which pleases your aesthetic judgment more. One of the great things about the Python language is that it is easy to sort of swap out chunks of code and try something else. And that's even easier with version control and stuff. So what next? I've got a few things that you could do if you're interested after this talk. Firstly, some stuff to read. There's the data model reference, which is in the docs online. That's a fairly long, slightly wordy document about all sorts of things to do with how attribute access works in Python. It covers lots more than we've touched upon here. There's also a descriptor how-to guide, which is worth a read. Guido wrote a long post about unifying types and classes in Python 2.2. Now, that was quite a long time ago, but Python 2.2 was when new style classes were introduced. And this post discusses quite a few of the rationalizations for that. And it'll be good for your, just to get a better understanding of why things are as they are. And further to that, Guido's History of Python blog is worth a read on a Friday afternoon. And again, he goes into lots of the motivations for why Python has turned out as it is, as we know it now. Secondly, read code. There's lots of good examples in Django. I'm not really a Django person myself, but I think related objects are all implemented using descriptors. There's an interesting idea in SQL Alchemy called hybrid attributes, where you can look up an attribute on a kind of a class that represents some SQL, and you get back something different depending on whether you've looked it up on an instance or an attribute. That's also implemented using descriptors. In the Python source, there's an implementation of some of the ideas in the Eiffel programming language using descriptors. I don't think I've really got time to go into that now, but it's definitely worth a look. And finally, grep your site packages directory for the keywords under get or under set or under delete, and I'm sure you'll find more. And if you find any interesting examples in code that you use, do let me know. And finally, play. You learn by playing, I think. You can implement methods and slots and properties more or less in pure Python, and it's quite instructive to do that and to understand really what's going on. Tinker with the CPython source. That's perhaps download a separate version of the source code and compile that. It's very easy to do, and even if you don't know C, you can learn a lot by looking at what the code's doing. As a hint, grep for TP disk get, and that's a comment tag which is often linked to under get methods. And finally, I'm not quite sure why this is here, but work out why a class's dictionary has an attribute called under dict. I think once you understand that, you'll have sort of begun to master descriptors and attribute access and things. So finally, ignore everything I've just said. This is a rhetorical device, not an invitation to throw things at me for having got you out of bed half an hour earlier. What I mean by this is that descriptors are powerful, properties are powerful, but with great power comes great responsibility. And you have responsibility to the users and the readers of your code to make sure that you're not doing too much magic. So I think I'm going to end with the Zen of Python, and that just fits on the screen. I often find that the top two, beautiful is better than ugly, and explicit is better than implicit, can be in a kind of a creative tension. And I think working out when to be explicit and when to hide things away, and which of those is more beautiful is a task that we should all be working on. So that's me. Thank you. If you've got any questions, I'll take them.
So you showed the slots descriptors on the class, but is there an object that you can introspect to see the values in the slots without using this descriptor directly?
Yes. So
because the values are obviously not stored on the class because they're different for each instance.
So they're actually stored in a, well, I think in an implementation specific way. But there's Python creates a space in memory just for those particular instances. So for those particular attributes, when a particular instance is instantiated, you can access them through just the usual dot notation. But I don't think there's any other way of accessing them apart from the dot notation and the descriptor. Sorry? Or C types, yeah.
So why is it that slot lookup is faster than attribute lookup?
I don't know exactly. I think, so whenever you do A.B, what that actually results in is a call to object.getAttribute, I think, passing in A and B. GetAttribute is written in C. I think one of the first things it does is it checks whether the class has slots or not, and if it does, it takes a different path, and I think that's quicker. But Harry?
Wait.
Well, I'm no expert, and someone correct me if I'm wrong, but I think it has to do that with the way it's used, like the use case for that, which is when you have a small number of attributes, and that it just does a very simple linear search, as opposed to having to take a hash and maybe deal with conflicts and like go through. That's right. It's just for simplicity. When the situation is simple, just go like 5, 10 attributes. Just do a simple linear search.
I can believe that, but I think you'd have to check, and Larry is shaking his head.
I'm not sure exactly about the mechanism, but I can tell you that the slot, once you know the name of the thing, it has the index, and it just does an index straight into the array. So the slot object really just has a little array inside of it, and it's kind of like locals access being faster than looking up a generic name.
Sure, but you've still got to get from the name to the index, and I'm not sure.
Right, and I think that's actually done with that member descriptor thing that's in the class.
Okay.
And so, to be honest, I'd be kind of surprised if it was faster. I think slots are mainly a memory optimization. Are they? Okay. Well.
Something else to investigate anyway. Good.
I think we are done. Yeah. Thank you, Peter.
Yes.
Thank you.
This one? Yeah. Thank you very much.